Hi all, thanks for coming. So my talk will be about malware once the clicker starts working, so that's interesting. Hold on. My talk will be... interesting where it worked before and now it doesn't, of course. So, there we go, it is. All right. So this is where it all started for me, the whole research. And of course, most people know this, right? Where there's all kinds of malware or ransomware nodes that are being used. Some are older, some may not exist anymore, like Maze. But that was the primary goal of my research, and it started out there. So I'm Olaf Hartong. I got announced already. I'm the co-founder of Falcon Force, which is a company in the Netherlands. And I primarily focus on detection research. So all kinds of behavioral kind of like detections. Sometimes I still do IR. I never studied anything in computer science. I used to be a documentary photographer. And for some reason, I ended up in the security space, and I actually really like it. I have 2 young sons, which I really love to bits. And of course, I like warm hugs, like the frozen Olaf does. So if you want to reach out to me, these are my contact details. If you have questions and you forget to ask them, it's always good. So how it really started for me is over a year ago, there was this article by Katalin Campanu on the ZDNet website. He now works for another page, but definitely follow his work. He does really good reporting. And what they did is they made a sort of dissection between the ransomware that got executed, but the primary malware that actually got in there. So the initial payloads are usually different than the ransomware that they executed. And what they made is a sort of overview of all the bigger initial access vectors with the malware that was tied to it, or it was known to be executed by them. So basically, in the end, they had a sort of listing of all these families, and then sometimes there are some duplicates, but this is a long list, right? So that didn't really work for me. What I usually try to do is visualize it, and then it makes it a little bit more readable for me. So you can see all kinds of correlations starting to develop. And this is, of course, a very small subsection of the real world. But this was an interesting factor for me to see. Let's see if I can start building detections on the initial vectors that aren't being picked up by the normal AV or the EDRs, to see if I can do something with the behavior that might not lead to that ransomware stage in the end. So that was sort of the goal of my research. And some of the interesting bits are where TrickBot was using Ryuk, and then later on started Conti, which is actually a sort of new version of Ryuk. So these kind of things were interesting, right? And then all that rebranding that constantly happens. This is from Brian Krebs. And I think it's outdated already because RAMP is now there, and there's all kinds of other spin-offs there, and they're constantly redeveloping even their brand image, where they now are using all kinds of fancier, almost corporate-like logos. Some of them are interesting. Payload.bin, I'm Dutch, so Miffy is very famous. It looks quite like it. So it's a bit of copyright infringement even going on there. But the interesting bit for me was like, hey, if they rebrand, are they also changing their tactics, and how are they developing, and are they cooperating with each other? So these were all kinds of hypotheses that I wanted to further develop. And in terms of marketing, some of these websites look quite nice, right? It's pretty logo, nice colors, but it's also kind of conflicting where they say if you're a client of us, but they also mention that they're a cartel website. So they're not completely sure what they are yet, but also Grief comes with all kinds of interesting marketing material where they have, of course, very good numbers into their direction. But it's kind of weird that they are starting to develop more and more into real-like companies. Of course, their business model is kind of weird, but also they have all kinds of fancy proclamations where they won't attack hospitals or other institutions. And they have all kinds of sort of company profiles, and they even go as far as partnering up with all kinds of affiliates, which is now more common. And the weird thing even is they do all kinds of fancy metrics that you can also see at some of the vendor websites, where they compare their crypto and their exfiltration tooling against the other ones and how fast they are. And if you don't believe them, you can even download all the samples and do the executions yourself. So it's pretty weird for me. And sometimes they even promise you not to attack you anymore, and even provide a list of recommendations that you should improve so that you don't get hacked, at least by them anymore. So I still don't know what to do with it. And now even Conti is breaching into the area where they might compromise a hospital, but okay, they won't ransom them anymore, but they will sell it to somebody else that actually does. So their standards are lowering, I guess. But back to the initial vector. So what I try to do now is look at MITRE ATT&CK and see which of the actor groups that are known are actually executing these initial payloads. And there were a couple of things that are standing out for me already, where you see there were 18 malware families before, and we only see a couple of groups being tied to it. And even not even all of them are mentioned in MITRE ATT&CK. So there's all kinds of conclusions that we can draw from this. So one of course is that MITRE only processes the data that is publicly reported and actually attributable, which isn't always very easy to do. So that is already a discrepancy that you have to account for. Plus that sometimes the software itself might be in MITRE ATT&CK, but there isn't a real correlation yet. So assume that MITRE is incomplete is probably the biggest mention here, which is fine. They do have a lot of valuable information, but there's always additional research to be done. And if you are able to disclose it publicly, please do, so that it can grow and more people can benefit from it. And on the other side, they only update twice a year, so it's always lagging behind. But in the Conti example, for instance, it wasn't on the previous slide, but it's actually known in MITRE. And as you can see, there's a bunch of techniques that they are known to be using. So it's actually already quite visible. It's just not tied to an actor group. So if you want to rely on the actor group model, which some companies still do, you might miss some important stuff that is actually going on already. And if you then look at this great spaghetti picture, it's basically what I did is I visualized all the software that we have and tied it back to the known attack techniques that are tied to it. And then you can see Conti over there as well, where it's actually there. There are some overlapping techniques. And what I like to do usually here is if I want to develop some new detections based on MITRE ATT&CK, I can look at where are the most combinations going to. That's more likely for me to build a proper detection on. Or I can catch more with one rule, basically. So that's one vector that I can use. But again, if I need to build detections, I need to have data. And you can get that in multiple ways. You can do it on your own by hand. You can reverse engineer it. I'm primarily a data guy, so I like to work with telemetry. So what I wanted to do is look at Sandbox telemetry, because then I don't have to detonate everything by hand. I wanted to do it at scale to see also an historical overview over time and a volumetric one. So I don't have to investigate one sample, which can be partially unique or heavily mutating. So I wanted to have a way of doing this at a larger scale. So I started looking at public sandboxes. There's a ton of them out there. They're really good, but they all have their different ways of working, right? So AnyRun has a free account. They all have a free access account, but they don't all have the same telemetry that I wanted to have. So I didn't decide to use those, primarily for the reason that they're great if you want to detonate a couple of files, get the reports, and then look at them. But it's quite manual. So most of the API access is actually in the paid version, or at least the important bits are. And as I mentioned, the output per platform is significantly different. It's like incomparable almost. So using multiple platforms at the same time didn't really scale well for me. And then of course I figured, well, VirusTotal is probably the biggest repository in the world. So let's have a look at that. And their API is actually quite verbose. There's a ton of information out there on it, which is quite easy to get. You can actually get it for free. But again, I didn't decide to use that for multiple reasons. So the API, as I mentioned, is amazing. You can download 500 sample or behavioral samples a day, which is quite a lot. And actually, if I found out you can also do 5,000 because they don't really enforce that limit. Probably they will if you start hammering it every day. But I never got to that point. So I started analyzing it. You get a lot of behavioral data. But one of the problems at the VirusTotal website is that they have their own sandbox, But there's also all kinds of vendors, as you can see over there, that also do that sandboxing of that telemetry. They feed it back into the API and you can download that. But if you look at the comparison, you can see that for one specific sample, there are multiple sandboxes and none of the data is close to even being an equivalent of each other. So some do a very verbose registry read or deletion, others don't even show it to you. And that's the same for the whole string. And this is only a subset, of course. But these are at least values that I find valuable, where I look at the command line or the strings or the DLLs being loaded, which I can actually utilize in building detections. But most of them are like uncomparable. So there's no real trustworthy real source. So I started looking around, and I have one friend named Luciano, and he has a very big Cuckoo environment where he runs about 4,000 to 5,000 samples a day. And he has a collaboration with VirusTotal, so he allowed me access to his Cuckoo farm, which he heavily customized to do all kinds of sandbox evasion detections that he mitigated. So the likelihood of it being properly executed is quite significant. And the cool thing about Cuckoo is that it also allows all kinds of plugins. So you can even look at the macros, you can decode those, and you can log that all in the behavioral platform. Plus you get all the relevant information that we saw before, even API calls, and it's all being loaded. It's all being logged by the same way. So it's all in the same format. So it's quite at least a trustworthy single source for me. I might still miss data, but I miss it for everything. Or I have it for everything. So that's the good thing about it. So now I had all that access, all that data, and these were like huge JSON files. So I needed to do something proper with it instead of grabbing. So I decided to use Microsoft Sentinel, as it's called now, primarily for the reasons that it's cloud hosted. So I didn't have to set up a huge infrastructure. It's super fast. Their query language is called Custo, and yeah, I work with it quite a bit also in my day-to-day practice. So that made sense for me as well. So it's really powerful. You can do all kinds of SQL-like joins and these kind of things. And it had a nested JSON support, with some of the data analysis platforms like Splunk. They sort of do it, but then they still segregate all the data, so it's harder to correlate. So these were the primary reasons for me to work with the Sentinel solution. And then you need to ingest it, of course. So there's a couple of ways to do it. You can use normal syslog, but that doesn't really work well for large JSON files because of the limitation of the length. You can work with the API directly, so you can fire immediately with a key to the API, or you can use Elastic's Logstash, which is an open source freely available product, and Microsoft has built a supported plugin that you can actually use for that. And that chose to be decided to be the most ideal way of doing it at scale. So that sounded really easy, right? But it turned out not to be entirely easy, because of course every API has weird limits. And Logstash also didn't really work well with large, pretty formatted JSON files because of all the line breaks. So I had to reconvert them into a single JSON blob first. And then I also learned that the API will break if you have more than 4 layers deep of JSON. So I had to also reformat the data already. Then it turned out that there's a 64 kilobyte limit in the field size. So every data entry point can only have 64 kilobytes of data. So that's usually enough, right? It's quite a lot of data for one field. But if you look at, for instance, registry reads or directory enumeration attempts, that can be a pretty lengthy list. So that got truncated. So I had to pre-truncate that already, split it up into multiple fields to at least circumvent that limit. And then if you, at first I downloaded like a year's worth of data, and I just firehosed that into the API. And turned out that the log analytics API on the backend didn't really like that. So it started rate limiting me with saying, hey, the payload is too large. But that should usually be fine. But Logstash can't deal with those messages. So it just keeps on hammering it constantly. So I had to do it basically at sort of my own rate limiting in there. But in the end, it worked out, right? So it was great. I have data now. I can actually search through it. The weird thing with the log analytics thing is that you need to build additional parsers on it. So it's actually readable, but they make it all into strings and integer fields. So you need to make it a little bit nicer. I work with Defender for Endpoint a lot. That's Microsoft's EDR. So I basically built a parser that had that same data schema so that it can easily convert all the rules that I started building on my malware to their platform with only changing the schema header field. So I now have a year's worth of data. Interestingly, the largest sample is 638 megabytes, which of course is an ISO file with a whole operating system in there to deploy malware. And the smallest one is only 682 kilobytes, or bytes even. And there's everything in there. So exe files, MSIs, DLLs, all kinds of Office documents, weird scripts, ELF files, you name it. So with that custom parsing, I had to do some other magic because due to the cuckoo nature, you can use all kinds of fictitious usernames, for instance. So I had to transform all those usernames at least into one because I wanted to correlate it across the whole data set. And then you have to do some additional JSON parsing and these kind of things. So it's not that difficult. But then you end up with all kinds of malware API call-like events where I can just very easily query that schema and have my own data representation in there. And I can even look, as I mentioned, into macro code where you can get the fully obfuscated macros that they're trying to execute and even decode that partially within the query language. So it's pretty powerful. So why would I go through all this trouble, you might ask? Because it's a lot of work for maybe nothing. But what I wanted to have is sort of very realistic and actually current vision of what is actually being used by all kinds of malware families, how they operate, how often do they change tactics, these kind of things. But also which lol bins are they using frequently, or which DLLs are they using, registry techniques, all kinds of persistence methods. And even seeing which is the current hot C2 platform, which is of course heavily debated on Twitter. But even go further where I can see, okay, they're enumerating certain directories or certain registry keys all the time. So I might be able to build a SACL on Windows already to monitor that more easily as well, because that's a hard thing to monitor with most security solutions. Even Sysmon can't help you there. So you can build additional visibility methods as well to see what actually they are currently doing, and also is sort of basically anything that I can build detections for. That was the whole effort. So this was a screenshot from yesterday. So currently I have about 825,000 samples in there, spread across over 4,000 malware families. So quite a lot. And I started building some dashboards just to make it easy, where I can also see which are the top 10 malware families that I at least have telemetry for over the last couple of months. And that might be different than the complete world, right? Because this is only a subset probably. But you can see that TrickBot is quite popular. Agent Tesla. Sometimes you see Cobalt Strike popping up, or Drydex. So it's interesting to see also campaign-wise that sometimes some groups are way more active than in other periods. And in summer, everybody was on holiday, so nobody did a lot. But also other things. So I can also look at the MIME types, for instance, where I can see a distribution of types of files that are being executed. And so suddenly in October and 2 weeks ago, there was a huge spike in Excel files being used again. So I could look at, okay, which families are now using that way more than apparently they do commonly, and what is actually they're trying to do. These kind of things make sense for me so that I can quickly build detections, help my clients, and be a little bit more versatile in these kind of detection and engineering efforts. But other things, like from a MITRE tech perspective, as I mentioned before, it might also be interesting, where we look on the left, we look at the techniques that are unique to Ryuk. And then you can in the middle see where Conti and Ryuk, which is basically a revamp of the same tool or the same family, are using still the same techniques and also stuff that is unique to Conti. So this is based on MITRE ATT&CK. So I also wanted to see how this does actually look in practice. So maybe for the people that are familiar with Bloodhound, this is just Bloodhound, but I use it for a different way. So you can use the Neo4j database in the back, populate it with anything you like, and I build a custom fork to have my own logos and my own branding or my own images to make it a little bit more concrete. But it's basically just Neo4j and with a nice graphical representation. So from a practical perspective, you could also have a look at all the DLLs, for instance, that are loaded by either Conti or Ryuk. And then we can already see that a lot of them remained the same. Well, you can't really see it on the screenshot, but you have to trust me that 30 were the same. There were a couple, I think there were like 6, that only Ryuk used. And now Conti is using 23 new ones that I haven't seen, at least in my data set, that they are utilizing. So that might give some indication that their behavior is changing, or they're using different tactics. Maybe they're using APIs instead of direct calls. It can still be anything, but it's already quite indicative that they're constantly changing their game because they need to, right? They're getting detected and these kind of things. And that's also where one of the law bins is searchutil. Ryuk never used it, but Conti actually uses it to download their second stage payload and then execute that. So these kind of small things are already interesting. If you don't have a detection for these kind of simple law bin behaviors, it might be a good reason to now start doing it just because it will give you some nice results, and it's not really used a lot in most enterprise environments anyway. And the same goes for run DLL. That's probably the most popular law bin out there. Whereas if we look at the whole spread from a MITRE perspective, it's only mentioned to be used by Egregore. But if I look at my data set, that's actually not true. And as I mentioned before, it might be that MITRE is lagging behind, or that they didn't have any public reports to base it on. But I can also see that Conti is actually using this quite significantly with all kinds of weird file names. But so they do. So I wanted to have a look at it a little bit deeper. And basically, the run DLL command line is built out of in 3 sections, right? So you have the process itself that needs to be called, and that can be called run DLL 32, but they can also rename it or even remove the exe. That doesn't really matter. Then you have the DLL, or at least the PE file that has to be loaded. Can also be called anything, as you can see already. And then there's a function that you first want to call. Instead of DLL main, which is executed by default, you can give it any pointer that you actually want to do. So this was something that already is being used by multiple families. And I wanted to have a look at, okay, what are the top used for first called functions that we actually use? So there's one that is quite prevalent. That's the DLL register server. There's also a sort of test RASM something that was only there for 2 days, and then it completely was gone. And there was the control run DLL one that was quite prevalent in the beginning of the year, and then it suddenly stopped. So I first looked at that, and I figured, okay, I wanted to figure out who is actually using this. And it turned out to be only one family that also was quite visible, like, hey, Emotet got taken down. And you can immediately see that in the graph as well, where it was actually a couple of days sooner than the tweet. So I'm not sure whether they announced it later, or my data source at least didn't have any new samples of them anymore. But it was quite interesting to see. And also, guess who's back now? So a couple of days ago, they still are coming back with the same technique. So they didn't even change, which is quite interesting that over such a long time, they still are using that same DLL function. And they're still one of the few ones that use it. There's now a couple of other groups that are using it like very sparingly, where you see a couple of samples, but it's super rare, which is weird because they can call it whatever they want. But still, they like doing it this way, and they don't get. It's a very simple detection to build even this. So back to that the DLL register server one, you can see that there's a couple of more groups. Most of the groups actually that we wanted to track in the beginning already, but also Drydex and Zloader sometimes use them. So that was quite interesting to me, at least, to see, hey, what is this? So I first started looking at the whole data set that I had. And started looking at what other function names are they actually calling. So they usually do the DLL register server, but sometimes they switch it around and do all kinds of interesting names like mean letter, north course, might cow. So they use word lists probably, right? So that's a simple assumption to make. And sometimes they even do some sort of random strings which are always the same length. So we can build profiles around that if we want. But first, I wanted to just look at the DLL register server. So I started looking at a couple of client environments to see, is anybody using this in a normal production environment? And the only thing I came across was a client where they were still installing Microsoft Silverlight, which, well, most people are at least close to my age. So it's very old. It's a sort of the Microsoft's interpretation of Flash. which never got into a real success. But apparently some corporate application still requires it, even though it was killed in 2019. So that was the only thing I came across. So I was still interested, right? So this might be something to keep on tracking. So I started looking at the whole Windows System 32 directory to see if it is anything that is actually prevalent. So we can see that there's an export function in one of the samples. It was actually the only exported function. So that made it still interesting to me. There's a better view for you, maybe. So I started looking at the whole System 32 directory. And it's actually quite prevalent. So there's 921 DLLs or executables in the Windows System 32 directory that also export it. But still, I never see it being called under the command line. So that was still interesting to me. So I started Googling. There isn't a lot of documentation about it, but one of the few things I found on a Microsoft website, at least, is that it is in direct show at least used as a COM entry point. So then I went in the whole rabbit hole. I'm not really well versed in COM, so I had to dig into that rabbit hole to understand it a little bit more. So basically, COM is an inter-process communication protocol. Sorry. So you can set up a COM server, and then other tools can actually talk and use that same code base to reuse in all kinds of functionality. And it's actually very significant still within the Windows environment. Even though it's a quite old setup or implementation, but it's also something that can be heavily used for all kinds of hijacking and all kinds of other things. And the reason is so everything is registered or stored in the register. So if you want to instantiate a new COM object, you look at the registry and basically ask for the class. And basically everything that is read by the operating system, they read from the HKey class root, and then the CLS ID, the class ID, and then there is a GUID, so global unique ID, that it identifies your COM service, so to say. But that top one is actually a virtual hive, so a virtual registry hive, which is a combination of the HKey local machine and the HKey current user. And the interesting bit is, so HKey local machine, you need to have system privileges to write to it, so that's slightly more secure. And the HKey current user, you can just write to as a current user, right? That's hence the name. But the interesting bit over here is that the HKey user always takes precedence over the HKey local machine, which is kind of scary in a way, because you can always override something and the user key will be read. So you can already imagine that you can hijack this stuff, which can break things. So you have to do it, not do anything. But it's kind of interesting to see. And then next to it, next to the global unique ID, you can also assign a proc ID, which is a sort of canonical name. You can call it anything you like. And this is again something that you can store in the current user space as well. But generally, within one of those class IDs, you have to use the improc server 32 or the local server 32 to store your PE binary, to point it to what should be executed when you want to instantiate one of those COM objects. And while it's very old, I still wanted to investigate, so how many COM objects are there if I just spawn a new Azure Windows 11 box. So I started looking a little bit through those hives, and it turned out to be 12,000 class IDs that are already present in the OS. So quite a bunch, right? And I didn't do anything. I just launched the Windows 11 box, didn't touch anything. And I also started looking, so okay, how many are actually pointing to a file that doesn't exist on the disk. So there's already quite a bunch of them. So 37 in total that are being called frequently, but don't have a file assigned to it. So just hijackable, just for you to take. And that's on a fresh OS again. So then I started looking with Procman just to see how many of those calls are actually being made within a maybe 10-minute period. And there were like 305 calls for different kind of binaries. So quite a large set of commonly used binaries. Explorer is by far the most noisy one, where they are calling all kinds of class objects that don't have a file tied to it, which is epic for persistence, right? You just need to assign it a binary, and it will be called every time, which can be noisy. You don't want to have 50 beacons being spawned, so you have to select the one that is actually useful to you. But with some lie, this took me like 20 minutes to set up and research. So if you spend a couple of hours, you can probably find some. But the biggest lesson learned is once you start building a golden image, go through it on occasion and filter a lot of those keys out, because most of the time they don't have a real reason to be there. Apart from maybe there is a legitimate reason, but then one of the installers that you might use will fix it for you. So just get rid of them. So back to that DLL register serve 32, right? So that again was one of the things that could actually write COM objects. So it turned out to be one of the functions for, at least for indirect show, but you can use it generally to store COM objects. And in the documentation on the previous page, it mentioned that it usually should be done through the redshift32 binary, which is also a low bin. But looking through my whole malware repository, I could only find a couple of instances that were actually using this on the command line. And the only ones that I could attribute or were attributed were apt32 with this weird long stuff. So usually it's done in a different way. So it's either an API call or it's something done by an installer, and you don't see it on the command line. So it's also very rare to see. And if you want to learn a little bit more about comms, these help me the most, especially James Forshaw and Casey Smith. They have some great research there. And if you want to look into hijacking, that David Tullis did an excellent DerbyCon presentation in 2019, where he also released some tools to make it even easier for you. One of the other interesting websites that I use a lot for binary checks as well is the Strontick Encyclopedia. It's not the easiest name to pronounce for me, but they have a ton of information about all kinds of executables or DLLs, which are commonly seen on a Windows box. You get hashes, all kinds of abuse methods, and generic command line output. So it's also easy to see what the tool is capable of. But they also have a COM library where they show you all the COM objects and the commonly used DLL names and these kind of things, which can be very useful. Because a lot of the COM objects don't have a canonical name assigned to it, so it's pretty difficult to understand from a GUID what is actually being done there. So this might help a little bit as well in your research. So a lot of things. What can you do with this function, right? So you can actually register COM objects, you can change it, you can make altercations with it. So one of the things is also a no-MITRE technique, is you can do component model object hijacking, or COM hijacking in short. And one of the things that at least Agent Tesla is commonly seen doing is where they actually hijacked or override the Google Update service with their own binary attached in that improc serve 32 location, where they first launch their own persistence methodology, and then of course sure they update Google as well, and then override that same key again whenever it's needed. But it's a great way to gain persistence or get code execution in the first place. So some of the other things that they can do is they can enumerate or even change scheduled tasks on the system. They can look at the recently opened files or just do a directory enumeration through COM, so you can hardly see any APIs being called, which is kind of nice and stealthy. They can also set up their own connection, sort of interfaces to create listeners to create some additional functionality. In some cases, they use a very old deprecated UCOM connection point, which should be dead, but it still works, even on a Windows 11 box. And then they could use all kinds of other telemetry that I didn't really look into yet, but you can even do all kinds of RPC installer messaging, all kinds of enumeration tooling, even talking to the proxy host. So there's still a lot of stuff that I can do investigating this. But what they also can do is there's a couple of class IDs that are tied to the auto run, so the on boot events. So every time you boot your Windows box, these 4 class IDs are enumerated, and everything that is registered there gets automatically executed. And of course, you can see this with sysinternal's auto runs tool as well, but nobody runs that every day, or very few people do. And you can see that at least some of the malware families are using at least 2 of those. Not everybody. And generic, yeah, that can be anything. It's not classified, at least by my detection platform. But the other 2 are, at least for me, unseen yet. So going back to that overview, it's kind of interesting to see that quite a lot of the malware that I was first interested all use this function. And it's kind of interesting to see that only those groups are doing it, and not even all at the same time. There was a sort of sequential thing behind it. So for me, it's kind of interesting now, like, who is doing this and why are they doing it in sort of sequence? Is somebody doing it and reselling it, or are they reversing each other, which apparently they probably also do? And how is this being done? Because I couldn't find real sample codes of this implementation on the public internet, at least. There might be something on the dark web forum, but I never bothered to look that far. But it was an interesting thing to see, because first we see Cuckbot or Qbot or whatever we want to call it. There's multiple names for it, use it. Then they stop using it in the summer. And then after summer, or somewhere in the middle of the summer, suddenly TrickBot becomes very active with it. And now hardly anybody is really using it. So it's only the turquoise ones that are highlighted a little bit in September and October, and now it's sort of dead. So it's weird to see why these changes are there. Some other fun finds I had, basically just scrolling through the whole database, is where TrickBot is a known Russian group, and then somebody had all kinds of samples with bear.exe and HTM in there, which I found funny. One of the other things was I started looking at, okay, what level of profanity is in there. So I started digging through strings and file names, API calls, all kinds of other stuff. And it turned out that Dridex within a couple of weeks was the most using the most swear words, which was also sort of interesting. It might help a little bit in profiling groups, or not. So what can we do with all this information, right? So from a detection perspective, we can have all kinds of, based on only this research, build detections on the Redshift 32 and the run DLL command lines, the functions that are being called, and maybe even go further, reversing them a little bit to see what they actually write to the registry if we don't have that telemetry there. So we can also have a look at the registry telemetry. So if you have a proper EDR or Sysmon or something like it, you can also see all the telemetry that they feed into the registry, what they are actually writing, which files they are actually registering. You can pull those and see what it's actually doing. And of course, you can look for anomalous COM objects, which is quite simple in general to do. If you have a very solid, well-maintained enterprise, you can sort of profile baseline what is commonly seen there and build some additional stuff on top of it. And of course, you can also start building mitigation, right? So as I mentioned in your golden image, you can unregister a lot of those sort of ghosted objects to at least prevent those from being reused. You can change the path of the ones that were improperly linked. So sometimes they only use a DLL name to link it, but you can change that to the full path name where it's actually there. So you can can't do the DLL hijacking methodology of just having it in another directory and probably being loaded with prevalence. And you can also use Microsoft's app control to block some of the known malicious class IDs, which is a lot more work, frankly, but it's super powerful because then it can't even be overwritten from the HKey's current user. And from there, you can probably do additional mitigations where you can start building all kinds of pattern base. So in summary, I like Sandbox telemetry a lot because I can see new behavior, I can see changes in behavior. I can also use it as a sort of, does this actually happen in the real world scenario where I have come up with a new idea, see if it is already being executed by someone, and then maybe get some new ideas from it. But it's also, I need to be aware of this is far from complete, right? This is only the data that actually executes in my sandbox. So if they have better malware evasion than I currently try to mitigate, it will die and it won't execute whatever it does. Plus, this is only the initial stage. So most of the interactive stuff, if they actually, so usually it calls back to a C2. I can see that, but whatever happens afterwards, when the attacker actually tries to go interactive and starts doing all kinds of other stuff, I can't see that in this data set. I might have another one for that, but that's way harder to maintain. And it's also a little bit more dangerous because I don't want to be attributed as running one of those honeypots for them. So that data is also missing. So it's definitely just a start. But definitely, in general, if you're trying to build detections, never look at signatures, or at least as little as you should, and look more at the behavior. So they run something, and then probably something runs afterwards, which is more valuable than all the small signatures that can help, but they're easily bypassable. You can even use a different class ID or something else. So looking for just a single GUID doesn't help you a lot. And one of the more generic concepts probably is to know the visibility of your tooling. Every EDR has telemetry. Some is really good, some is not so good. But even the really good ones filter data. So maybe you're trying to search for something that it isn't even logging. So you might have a blind spot there. You need to augment that with another tool or talk to the vendor to actually start onboarding it, and get more visibility that way. And the only way of doing that is just doing it in labs, repeating yourself, and also validating. You can build pipelines for it if you want. But this is a very interesting bit where you can't really trust the vendor that isn't disclosing to you what it's actually monitoring. So you need to make sure that you know it yourself. And again, attack is amazing. It's really useful as a generic language to communicate what is actually happening, but it's never complete, and also it will never be, because it's maintained by a small team of hardworking people, and they rely on public information that is actually that they can fact check. So if I do an assumption and write it, it's probably not ending up there because it needs to be backed with actual data. And ideally try to build mitigations first before you start building detections, if you can, because that's always a more protective measure, because you stop them in the first place. So that was my talk. Thank you very much for being here. If you have any questions, feel free to ask them now or find me somewhere else. I'll be at the Armory right after to talk about a Sysmon tool that I built and a threat hunting app on Splunk. Thank you.
We have 2 questions from the AirMeet app. What's your recommendation hunting for anomalous objects? Are there low-hanging fruit in an environment?
Yeah, the low-hanging fruit is probably looking at either overwriting some of the known updating services like Google Chrome or Firefox or some of the other ones, where it's quite common for the malware actors to make spelling errors. So these are quite low-hanging fruit. And the same for the auto runs, and some of these quite heavily used scheduled tasks is definitely one. So those are the most prevalent, I guess.
Okay, nice. And the second and final question, what's the most interesting malware evasion technique you've picked up?
Oh. Well, out of the top of my head, it's probably interesting to see that I work a lot with the Sysmon telemetry, simply because it's so configurable and I can actually determine what I want to see and what I don't want to see. And what is interesting that from the whole data set I have for a year now, that almost nobody tries to kill Sysmon in the first place. And even red teamers don't do that a lot. So simply, my assumption is that they don't want, it's not stopping them from doing what they want. So they don't care for it, where they do kill a lot of the EDRs with some interesting ways. So they try to kill EDRs or AVs, sometimes just stopping the service. Sometimes they go a little bit further with injecting into a driver and then trying to kill it. So these are the most interesting ones that I can think of right now.
Cool.